So now you may have seen him already in the last video, but Cameron McIntosh from Americhanvre is here. And he is joining us from a project site that he just came from yesterday. So you're in for a real treat. And here's Cameron.
I'm a little taller than Lori. Thank you very much, Leslie, Jenna, Green Building Alliance. We often get asked to speak at hemp industry specific events, and there is no ground to gain in that room. You do not have to convince a bunch of people at a hemp conference that Hempcrete and hemp building materials are awesome. So this is the kind of meeting that we need to be at, in a room with folks like you who are design professionals, state government, local government. This is really important for us. I just want to give one shout out really quickly to Drew Oberholzer. Actually wears two hats. He is a really excellent video and film editor, and he actually edited those videos that you saw. So how cool are the videos? So just had to get that in there. So anyway, I'm going to try to move through this. I do have more pictures of our work in the case studies portion of my presentation, which is going to happen later. That's a teaser to make sure that you all stay here long enough to see that. Well planned, Leslie. And again, thank you, Leslie, for all of your organization and all of this. Guys, Leslie had a very serious document for all of us on just exactly what was expected of us today, which we very much appreciate. And again, is not something you find commonly in a hemp specific trade show. So Green Building Alliance showing their professionality here. Yeah. Okay, so just a quick introduction. I own Americhanvre Cast-Hemp, along with my wife and business partner, Melissa. We're out of Allentown, Pennsylvania. We are a supplier of certified building grade and animal bedding hemp herd. That was my warehouse that you saw in the video there. We do import that from France. More on that later. We are essentially an installation subcontractor and consultant that specializes specifically in the installation of Hempcrete. And I do have to apologize to Leslie. One of my jobs today was to talk about all of the hemp building materials. I am shamelessly going to just talk about Hempcrete because there are great examples of the other two notable ones, which are the hemp fiber bats that you can find over on Drew's table, and the hemp wood in the back on the counter there. So you can look and feel and touch those. And I'm going to, again, shamelessly talk about what I know best, which is Hempcrete. So we are the U.S. distribution partner for the Easy Hempcrete spray applied Hempcrete system, which you saw a little bit of in that video. To date, we've imported over 1 million pounds of hemp herd for construction from France. And we've installed over 30,000 cubic feet of material on residential homes from Virginia to Vermont here on the East Coast, and as far west now as Washington State, British Columbia, Montana. I am also on the board of directors for the PA Hemp Industry Council, and I also help to co-write the IRC appendix for Hempcrete construction that I'll talk about a little bit here. As mentioned earlier, for those of you that are design professionals, that will be added to the 2024 update to the IRC. As we all know, that doesn't mean that Pennsylvania will have accepted that update, although its mere existence makes it much easier to get approved for projects than it was previously without it. So that was a big deal. So what is Hempcrete? Very important to note, it is a non-structural, self-supporting biocomposite insulation and walling material. Hempcrete is a terrible word for it. It's nothing like concrete. It's not meant to be used at all in the way that you would use concrete. Again, self-supporting but non-structural. So it's comprised of a mixture of the inner woody core, as Lori mentioned, the herd of the fiber industrial hemp stalk, a lime-based binder, and water. It's been in contemporary use since the late 1970s in France as a substitution for failing wattle and daub infill in what you can picture would be old provincial French architecture, timber frame architecture. Hemp and lime have been together and have been documented in projects over thousands of years. There's a series of caves in Ellora in India that they've documented the use of a hemp fiber with a lime plaster to preserve a fresco So although the material hempcrete, again, has only been in use in contempt, the way that we're using it since about the 70s, the two materials have been together for thousands of years. So that's a little bit of a hempster myth that hempcrete is thousands of years old. It's not, but hemp and lime have been friends for thousands of years. So yeah, robust use in the UK and France. We're seeing, quite a bit of commercial work happening, and quite a bit of residential work happening in the UK and France. Markets are opening across Europe, Australia. There's a big scene for hempcrete building, and now here in North America. It is fully approved for commercial and residential use in France and the UK, and again now for us here in the United States. A little bit on the material properties. Again, this is my spiel on how it is not concrete. Despite the masonry-like qualities, hempcrete is nothing like concrete. The density is about 15 to 22 pounds per cubic foot, as opposed to concrete, which is roughly 150 pounds per cubic foot. There is no slump. When you place the material into a void or into a form like concrete, it will not escape a form once you've packed and placed it. And it has very low compressive strength. So again, it is very much an insulation and walling material before it is meant to be structural. It does display obviously impressive thermal performance via the matrix of trapped air pockets that we're creating in the wall. And the fact that it is cementitious in nature, and it does have mass as compared to other insulations that don't have mass. So one of the most wonderful things, and one of the things that I think draws most of our clients to us, is the fact that it is a healthy material. We are in the midst of, as many of you know, as design professionals, what I consider to be a modern public health crisis, which is that we do not properly assign the impact that the materials in our homes have on our health. This was punctuated by the COVID pandemic. We spend 90% of our time inside a building, and the exposure to the materials that our homes are constructed out of is as impactful to your health as things like what you eat and your exercise habits, smoking, things like that. It can be just as bad for you. Extreme fire resistance. You will not hear me say it's fireproof. That slipped into our video somehow. It is fire resistant. It displays a high level of fire resistance. It is not fireproof. And also obviously the carbon storage potential derived from mostly the plant. I'm not going to go too deep into this because Anna has a lot on her slides about this, but the majority of that carbon storage potential comes from the crop itself as it grows, again in 6 months to a height of 7 or 8 feet. And the woody inner core that we use for building is 75% of that stalk. The other 25% would be the fiber, the oil, the seed, things like that. So we are taking 75% of that stalk and locking it away, for anywhere from 1 to 500 years, we hope. So for those of you that are looking for tools for working this into your embodied carbon estimates, if any of you are doing that, the beam estimator, I'm sure some of you are familiar with that. Also building transparency, they have a couple of great tools as well that now have some values for this material. So the three main installation methods, the first and the traditional method of installation is cast in place on site. The material is mixed and installed around a traditional wood frame with a pair of slip forms, much like concrete, on either side of that wall to create the void into which you place the material. Tamping tools or your hands are used to situate the material. We tamp a little bit tighter to the face of those forms so that we have a nice compressed surface for plaster, and we leave it a little bit more lofted in the middle, again because we're trying to trap as much air as possible. This is always going to be dear to me. It's the way that we all started. Drew and Anna and I built a small tiny home on wheels this way by hand as one of the first things that we did. And it is the most accessible method. So it only requires basic carpentry tools and skills. It's a great community building exercise. If you have a big tribe around you, this is the kind of thing to do. It is difficult to imagine this becoming widely accepted, doing it by hand. And especially for larger scale projects, which is what precipitated my interest in spray application and Drew and Anna's interest in prefabricated components. So Yeah, a couple pictures of that. This is a retrofit that we did. You can see again how the material is being placed around, you know, an armature frame, which is the wood there. We move those forms up immediately. Again, there's no slump. This material does not escape that form. We can move it up as soon as we fill it and keep packing. As you can imagine, when you get to the top of the wall, the game changes and it is not fun anymore. So that's where you know, a precast element or a spray applied system really excels and draws the line. Spray applied hempcrete, my favorite. The materials again are mixed on site. They're introduced to the wall pneumatically, so we're using air pressure and a specialized hopper box that helps deliver the materials to that lance that I'm holding. Dramatic reduction in installation labor and overall costs compared to cast in situ. That home that I'm spraying right there is a 3,000 square foot timber frame in Vermont, 3 stories. It would have taken us every bit of 6 to 8 weeks to do that by hand with as many people as we could have attracted to the process. We sprayed that home in 8 days with 4 people. So you can see just how dramatic the difference is there. It is operator experience heavy, obviously, for the lance operation. That's something that you have to learn how to do. The rest of the jobs are just good old-fashioned manual labor. With this method, as you can imagine, we're removing the human element of hand tamping. So we have an increased consistency overall. When you see our work, you don't see what I believe to be one of the beautiful things about casts in place, which is the stratigraphy in the wall, the evidence of the different layers of compaction as it's being hand tamped. We don't have that with spray application. We're getting a very even and consistent placement density over the entire wall. And also surface tension with the framing members. You can see how that stuff is sticking to the wood as opposed to when the material is cast around the wood. Yes, it's trapped by it, but it's not really stuck to it. So this is something I'm excited to test with Ali and his shaker table in the underbelly of the PHRC department to see if we can, you know, demonstrate that the material being adhered to the framing is actually a positive benefit when you're considering out of plane load and things like that. So just a few images there. That's that same wall that was in the other picture on the right there. That's me spraying very late into the night. We actually sprayed that entire wall in one day, partially because we were losing labor the next day and there was rain coming. So it was a heroic effort, but we were able to do that entire gable in one day. There on my truck, you can see the 2 pieces of equipment that we use in addition to the, you know, French spray applied equipment. There's a large air compressor that is basically a Mack truck engine on a trailer. So we do consume more diesel, obviously, when we're installing this way. So that's one of the trade-offs with spray application from a sustainability perspective. And then the other piece of equipment is the Mud Hog, which is our horizontal shaft mortar mixer, made not all too far from here in Malta, Ohio. EZG Manufacturing is actually my contract manufacturing partner now for the equipment that was previously being made in France. We are now making that with EZG in Ohio. So we have, quote unquote, as nasty as this is to say, Americanized the equipment. And it's a little bit easier to use now in the United States. So precast and modular. These are systems like ready to use blocks like what Drew and Anna and Coexist are making, and or modular panel systems that are really exciting. So that project that Leslie just mentioned that I just left is a first of its kind full section wall panel tilt up project that we're doing in Newburyport with this material. So really exciting. We'll talk more about that. We'll also talk more about in the case studies section, these 2 cabins that you can see me installing Drew and Anna's block on, where we actually did a combination of precast block on the inside and spray application from the outside. So the biggest drawback with any precast method is obviously bridging at the joints, mortar joints in a block wall are denser than the rest of the block. In this case, we eliminated that by having the best of both worlds, which is a nice ready to use precast element on the inside, which allowed for the project sequence to continue with plastering while we sprayed from the outside. So we maintained a monolithic envelope and also got the speed and efficiency of having that precast element on the inside. So really cool. They are difficult to source. Drew and Anna are literally the only supplier manufacturer of these blocks on the East Coast. small business growing pains. We're all trying to get to the point where we're commercialized. In my case, it's finding someone to make a piece of equipment that I can take on site. In their case, it's finding the money and the resources to build out an entire facility that can do this at scale. So please understand that these products are available, but the ramp up for precast elements, whether it's blocks or panels, is obviously more expensive and involved than what I'm doing, which is open blasting hempcrete on people's job sites, which is a lot of fun. It's as fun as it sounds. So there's a picture there of the outside of that cabin where you can see a little bit of that detail. Again, this is in the case studies later, so I won't go too hard on that. Spray application from the outside, block to the inside, and a series of 4 foot by 8 foot by 9¼ inch thick pre-framed and sprayed modular panels designed by my friend Matt Marino at Homeland Hempcrete out of North Dakota. We actually use these panels in our warehouse when we're doing our training, so that I'm not taking people out to a job site, you know, someone's home to learn how to spray. They're doing it in a controlled environment in my warehouse on a precast panel. So construction details, there are 4 wall construction details available now in that new IRC index that detail how we would like to see hempcrete specified for a project. There is no change to standard wall framing details as per existing ICC recommendations. The only difference is that we have removed plywood and drywall, obviously, from the equation, which removes your shear load. And in place of that, we're using diagonal lead-in bracing or strapping. Know that when you place this material, in writing the IRC code, we were strategic in not asking for any consideration for its structural capacity. Number one, because we don't have any data to support that yet in the United States. There's plenty of European data, but pretentious American code enforcement doesn't take that. That's not acceptable. So we have, you know, had to demonstrate the use of this material in that IRC index as having 0 structural capacity. One of Ali's former students, Anthony Dente, is the engineer that we hired for this process, Berkeley-based, Penn State educated. He said to us, guys, you're going to have plywood or drywall somewhere in the equation. And we, of course, hissed and spit and said, no way. It's not vapor permeable, can't have it. And we actually did find an Italian out of plane load study that had been done that Anthony used in his calculations. So the IRC index, without any additional engineering documentation, will allow a homeowner to use the material as long as they are under 25 feet off grade. So knee wall, gable, everything has to be, you know, under 25 feet, which is essentially a single story home. That doesn't mean that you can't. Obviously, most of my projects are more than a single story. You just at that point would likely need an extra or an additional engineering bracing design to accompany whatever you're proposing. So that's if the code enforcement guy actually reads the index. Questionable if they actually do that. But yeah, so you can see, let me just go back quickly. You can see there in that detail how we're positioning it around the frame. It exists on either side. Traditionally, it's finished with a lime plaster on the inside and the outside because that maintains the vapor permeability. So the meditation for those of you that are in design with hempcrete is vapor permeability, but air tightness. So we do want an airtight assembly, but it has to be done in such a way that moisture vapor can move through the wall. The lime and the hemp hurt are both very hygroscopic. It likes to balance itself, which is wonderful for the you know, the livability of the space, and also for the thermal performance, as Ali would tell you, that has an impact on that as well. So yeah, couple different wall details. You can see the frame in the center. The frame to the outside is often for when someone or client wants to do anything other than lime plaster on the exterior, at which point we have to create and maintain a ventilated airspace or a rain screen detail for that specific use. And that is possible. The Wally Farms project, the combination of the block and spray, they actually did a ventilated rain screen. Some of our more higher end projects surprisingly have opted for a ventilated exterior rain screen, I guess either because plaster's not in vogue in their design circle, or, you know, actually in reality it is a bit simpler to detail and you're less likely to have water infiltration issues. It's hard to find a good plaster here. That's one of the big drawbacks with exterior plaster for hempcrete. And the developer that I'm working with in Newburyport, that was his overall sentiment, was that the exterior plastering of hempcrete is what's holding it back. So you don't have to put plaster on the outside is what I'm here to tell you. You can do a rain screen, and they're great. So yeah, Hempcrete's inclusion in the IRC. I don't have to describe the IRC to you all. We wrote and presented this to the committee back. I think it was in April of 2022. They accepted it. It moved into the open commentary phase, passed through that. We wrote the actual commentary that will accompany the document if you've paid to see that commentary on the IRC website. Again, it will be active in 2024. That doesn't mean that, you know, the state of Pennsylvania or any given state will have accepted that update, but the mere existence of this document makes our lives so much easier in terms of getting projects approved. So there's a little snapshot of the team that sat together to write this. You will notice at the top of that document some familiar names as proponents of it. Anna, as an architect, was one of a team of people that helped us to review and give feedback on the final document. And then a few of our colleagues actually helped to present it as well. So we actually hired Martin and David. I'll just mention this. Some of you might know them. David Eisenberg and Martin Hammer are two consultants who are responsible for the writing and inclusion of straw bale, light straw clay adobe, tiny home, and now Hempcrete. All four of those indices they had a hand in. So we scraped the money together to call them. They were awesome. And at a point in their lives where they didn't have to answer the phone for us, but they did because we were doing it from an industry perspective. So although, you know, my method of choice is spray application, this document covers cast in place, spray application, precast methods, and does a very good job of not drawing any conclusions for the reader that one is superior to the other. So this is an industry play. That's why Martin and David wanted to be involved. And we were very lucky to have them. So Leslie, how did I do? Time-wise, did I nail it? All right. So I'll be back. We'll do some case studies later. All right, who wants to hear about Project PA Hemp Home again? Just kidding. Yeah, love this project. There's Chris Lloyd on the front step talking to Lori. That dude and Lori are responsible for this. He's no longer with us, but this was his, you know, along with Lori, this was their yeah, I don't know, a great achievement. Anyway, so we won't talk much more about it. That's the plaster we were putting on. It's a hemp and lime base coat plaster that was then screeded over top. So you can see the guys there adding some of that on. That was pretty cool. Everybody, those couple pictures that I took of the hallway have just been like shamelessly thrown about by everyone in their presentations. So I'll just keep going here. Really great, beautiful little inside. This is a tiny little itty bitty house, but it's really, really nicely done, functional. Wally Farms too. I won't hang on this too long either because Anna, I think, did a good job covering it. Again, designed by Kaya, who's actually a professor at Columbia. She's the one that did that carbon research. And interestingly, just to make my my own self feel better, she examined the fact that we're shipping the hemp herd in from France and found that the 4 hours that it spends on a truck, 2 hours in France and 2 hours from Newark, New Jersey to my facility in Allentown is a larger carbon footprint than the entire sea freight voyage. So if you imagine about a 5 or 6 hour radius around where we are right now, or where we are on the East Coast, on the eastern side of PA, anything further than that would actually be a larger carbon footprint if it showed up on a truck than getting it from France. So believe me if you want, but anyway, yeah, just again, really, really great project. Beautiful blocks on the inside there. Really highly designed architecturally. There are hidden gutters in the roof. I'm still not sure if they'll live to regret not having any roof lines on these buildings, but you know, yeah, so really great project. There's a little image of the setup, the mud hog. We mix and we dump the material onto that table and then it gets raked into that box. This is the second building that we sprayed, same project, and there they are finished. So really, really gorgeous architecturally. Again, I'm not sure if you that design will end up being a problem for them, but it looks pretty damn good. So okay, so one of two projects here that I want to present to you quickly at the end of the day. The first of which is our eReezy owner operator partners at Lower Sioux. They bought an eReezy machine from us, and this is an emergency housing duplex on the Lower Sioux reservation that is going to be owned and operated by the tribe for families in crisis. So this again is probably, I think this is the only other multifamily hempcrete anything in the country other than what I'm about to show you next. They are obviously on an Indian reservation. They are not technically part of the state of Minnesota. If you want to get really angry, look into how and why the Lower Sioux came to be on this little postage stamp of a reservation that they're on. It's pretty maddening. They're not holding on to it though. They are a really, really awesome tribe, and they have a bright future in front of them with hemp. They framed this house and got it ready for Hempcrete in less than 2 weeks. It was an open foundation that had been in the ground for 14 years that had not been built on. They often hire in outside contractors to build for them. It's very rare, if ever, that the Lower Sioux actually build for themselves. So another really critical aspect of this project was that it was built completely by Lower Sioux tribe members. So, and they got it to that point. It was an open foundation in the ground. They got it to this point in 2.5 weeks. Which is insane. We insulated it with the eReezy system. As you can see, this is also the first time we tried sort of a crazy ass idea that I had, which was to put the membrane on first and spray against it so that we could avoid having to do the temporary forming process. Normally with spraying, we're forming one side of the wall or the other. This worked great. And you'll all be terrified to know that they have used vinyl siding on the outside of that building as part of the rain screen. Now, why do I think that's awesome? Because this is an answer for affordable housing on their property. Okay. And if it has to have vinyl siding, it's still got hempcrete in it, right? We were having this conversation at dinner last night. If this all or nothing mentality when it comes to sustainability is really going to back us into a corner quickly. It's no, that's Mento. There's Mento over the studs as the air barrier. That's not plastic, that's Mento. It's a vapor permeable high performance building wrap from 475 air tightness barrier. And there's an air gap there. So what else was I going to say quickly about this? They built this thing for under $200,000, including with a hempcrete, finished, lime plaster, furnished, 2 families. It's 1,500 or 1,700 square feet. So each unit's around 800 square feet, 1 bedroom, 1 bathroom. Conversely, there's another home being built on Lower Sioux right now by an outside contractor. They did cast in place hempcrete by hand, but because of the involvement of the outside contractor, that home, it's about 2,500 square feet, is costing them over $500,000. So just a dramatic, exclamation point on the fact that you can do these materials sustainably and affordably. It just requires some effort. Okay. This is the meat and potatoes. This is what I really wanted to get to, and I've probably eaten up my time already. So Leslie's probably already upset at me, but this is the Hillside Center for Sustainable Living in Newburyport, Massachusetts. This is where I just came from. It's a fully sustainable low-rise multifamily community developed by Hall and Moscow. They have incorporated solar, passive house, gray water, rainwater system for flushing the toilets, permeable paving, native edible landscaping. They literally did all of it in the same place. The existing units that you're looking at right here are constructed from concrete and EPS foam. These are full section tilt-up wall panels that they created flat on the ground with a steel moment frame, 4-inch concrete slab that faces the inside of the unit, and then 12 inches of EPS foam to the outside. So you're essentially isolating that mass of the concrete from the exterior environment so that once you heat it up or cool it down, even though they're not very sustainable with the concrete and the foam, they are incredibly performant. They did a whole bunch of air sealing and stuff. They even ended up using a little bit of that aerosol gel to find all the little cracks, which is very expensive, but it worked. We are working now on the south rise, which is going to look exactly like that, other than the fact that the siding on these ones with the concrete and the EPS foam is magnesium oxide board with a like reverse board and batten detail. The Hempcrete units will be lime plastered. And they're using the E-Reezy for this. This is very literally a first of its kind for the United States. We don't have anything else like it in the world. There is in Puglia, Italy, there is an apartment complex that's been done with this. In the UK, there's an affordable housing townhome sort of thing that's been done like this. And now in South Africa, although I'm not convinced exactly what is hemp in the building, there is also a skyscraper made out of hemp in South Africa. So really cool. So that's the south rise. You can see those are panels that we had sprayed. These small, where's your laser pointer, Anna? Oh, right there, the green thing. Yeah. These little sidewall panels, they sprayed all summer long. The large gables and this waste wall panel were actually laid down, as you can see here, sprayed, plastered, and then tipped up in a very short period of time, like in under a month. So here we are setting up to do the mirror of that. Six different, individual buildings here, kind of interconnected. Again, you can see there the E-Reezy setup, and down there, actually, there's another E-Reezy setup. So we actually did dueling E-Reezys on this project, which is really cool. Oh, right there, you can see it. Yeah, there we are, dueling E-Reezys. So that's sort of an image of me spraying. I don't think I have any videos of the spraying in here. I'm sorry, guys, but you can find that online. And then here is the application of the plaster process. So we spray the panel, we scrape it down or screed it so that it's level, and then we add a little bit of wood along the side there as a guide. And then we're using an Eimer Prestige 300 mortar pump sprayer to mix and spray the plaster on the flat. And that allows us the opportunity to make sure that that base coat is laser flat, because you have those reference points to either side, as opposed to having to do this once the wall is tilted up. So this is just a base coat of 3 coats of the lime plaster going on. And you can see there, the guys, as soon as we spray it, they go around and trowel it, lay it down flat. And then, oh no, wait, hold on. I don't have the other picture in here. There was a picture of the guys laying mesh in. So there's a layer of fiberglass mesh that's embedded into that base coat to give it some rigidity. But yeah, here's the tilt up. Sorry for the poor quality video. This is the very first panel going up and getting put into place. That steel moment frame has a big tab on the bottom of it that actually indexes with a piece of steel that's been cast into the concrete. So they are welded to the base and then bolted together. So we're not worried too much about cracking or earthquakes or any of that kind of stuff. So, and then the big lift, that's one of those big panels. This is terrifying for me to watch. When David told me how quickly he needed to move these things and how he wanted to do it, I said, we better try it first. Yeah, it's pretty intense. That panel, when it was concrete and foam, weighed 30,000 pounds. With the Hempcrete and the lime plaster, the crane weighed out at 10,000 pounds for one of those panels. So dramatic reduction in weight, and obviously embodied carbon, getting rid of all that concrete. So I think that's it. Yeah, there you go. You can see Tim's welding the panels down there. And right there, if you can see it, is the little piece of steel that's been embedded in the concrete. And then they all get bolted together. So so yeah, and a little montage of some other projects that we've been on. Hey, there's Project PA Hemp Home. Mike had that picture in his presentation. I'll be sending you an invoice. So yeah, I think we're good, Leslie. I'm sorry, I'm probably over time there. Yeah. Thanks.